Okay, now let's talk about this sheet, which is called advanced particle motion. All right, so why advanced? You've already done problems with motion. You've done position, velocity, and acceleration, but you've only been able to do that with derivatives. Now we have integrals, so we can solve more kinds of problems about motion, and so that's what's advanced about it. Why particles? Particle can refer really to anything. It really should be like object motion or just motion, but commonly this is called particle motion because you're really talking about an object that has sort of no size. Which seems contrived, but it isn't necessarily. Like we could be talking about particles in a super collider. That's where this kind of terminology comes from. But you could also be talking about a car or a rocket or something, because those things move according to their center of mass, which is a point at which all the mass is sort of the behavior of the object comes from the forces on that center of mass. You will learn about center of mass in physics. We might, at the end of the year, do a project. I think probably we'll do a project on center of mass at the end of this class. It's pretty interesting stuff. All right, so particles just means anything that's moving, really. All right, so these are the kind of problems we're going to do. So we need a little bit of discussion on the background of how integrals come into play. All right, so here is what we have: position, velocity, and acceleration. So what you already know is that if position is s of t, then velocity is s prime of t, and acceleration is s double prime of t. So these are just ways of saying things you already know. S is position, s prime is velocity, s double prime is acceleration. And what you're essentially doing as you go down this list is you're doing the derivative with respect to t each time, the derivative with respect to t. So we now know that now we have something called antiderivative, right? What is the function that this acceleration was the derivative of? All right, that's what we mean by antiderivative and integral. So the integral, so if we do the integral with respect to t on the way up this hierarchy, right, integral with respect to t, then we're going to be able to start with acceleration and get the other things, which is often what we have to do in terms of application, because a lot of times we know the forces on an object, which is to say we know the accelerations, and then from the forces on the object we want to predict what the position is going to be. So sometimes we need to go up this ladder instead of down it. Now, but something weird happens though. So let's just, for example, say that your position, your s of t, let's say it was 3t squared minus 4t plus 5, okay, just as a made-up example. Then v of t would be the derivative of that, which would be 3t squared minus, it would be 6t minus 4, right? Yeah, all right. So what happened here is I lost some information, like the 5 is gone. So I've lost that as I go down because the derivative of 5 was 0. And then the acceleration is just 6. So now I've also lost the 4. So as I'm going down this ladder, as I'm going down, there's a loss of information as I go down. Right, because I started with 3 pieces of information, a 3, a 4, and a 5. By the way, in terms of the physics going on back here, the information that I have up here is really like an initial velocity and an initial position. So as I go down to velocity, I lose what the initial position was. When I go down to acceleration, I also lose what the initial velocity was. So but if I just think analytically, there are numbers here that I'm losing as I go down. So if I wanted to go up this ladder, how would I restore? How would I know that this was a negative 4? How would I know that this is positive 5 if 6 was all I had to start with? All right, so as you go up this ladder, you need to supply information somehow. And so we'll look at what that looks like when we look at some specific problems. So as we go up, there's going to be a special problem that we can't find equations for position and velocity going up unless somehow some information is provided. And actually you can sort of glance over this and you can see how we start with a velocity, but there's also some information here, right? It tells you what s of 0 is, right? Or it tells you what s of 3 is. In this case, it tells you v of 0 and s of 0. Right? In this case, it tells you v of 1 and s of 2. So additional information is supplied in order to solve these problems. All right, so we're going to go through number 2. So number 2 says v of t equals t squared minus 4, and it tells us s of 3 equals 8. Now, so this worksheet is also asking you to do a different thing. Let's start with the simple things. It asks for an equation. So it's not asking for the total distance or the displacement. It's asking for equations that give s of t, v of t, and a of t for all t, right? So we know how to do some of it already, right? If we're given v of t, we know how to get a of t. A of t is just the derivative of v of t. It's 2t. Done. Simple. Okay? So that I do that just by doing a derivative. So the problem is when I have the v and I want s, I want this position function. All right? So that becomes problematic. And so I'll show you how that goes. So to get s of t, what I know is that s of t is the antiderivative of t squared minus 4 dt. Okay, now, so that's doing, the antiderivative integral. So there's some special considerations here. This integral, there's no interval here. There's no a and b. There's no a and b on my integral. So this is something called an indefinite integral. And so the indefinite integral is really just asking for the antiderivative as a function. So the indefinite integral is useful if you want the antiderivative, but you don't want a number, you don't want a numerical value, you want an equation, because that's what we're looking for. We're looking for an equation for s of t, not just a value for s of t. All right, so we can do that. We can do the same antiderivative that you always do. The antiderivative of t squared is t cubed over 3, and the antiderivative of 4 is 4t. All right, so notice I did not put evaluation brackets because I'm not going to evaluate it, because I can't, because I don't have limits. All right, this is an indefinite integral. Define means to put limits. Shall we do a Latin lesson? Why not? Indefinite. All right, define. Fine. Finito. Final. Means end, limit. Means to delimit. So to define something means to delimit it, to place limits on it. If I define something, I say what it is, I place limits so that it can't be anything else. So something that's indefinite has no limits. That's what this means. I'm doing an integral that has no limits. All right, so indefinite means no limits on my integral. All right, now, but here's a problem. All right, sure, t cubed over 3 minus 4t is an antiderivative of t squared minus 4, because the derivative of t cubed minus 4t is equal to t squared minus 4. But also, the derivative with respect to t of t cubed over 3 minus 4t plus c, where c is any real number, is equal to t squared minus 4. And c could be 100, c could be 1,000,000, c could be negative 20 billion, c could be anything. It could be 0. All right, so in this indefinite integral, you get some kind of ambiguity, which is that we end up with a constant whose value we do not know. So when you do indefinite integrals, you're always going to end up with this plus c. So a lot of times you will see antiderivatives written that way. So what's the antiderivative of t squared minus 4? It's t cubed over 3 minus 4t plus c. That's a standard way to write an indefinite integral. All right, in this case, we're going to use the information that we have to find out what that c is. So now we're going to bring this around, and we're going to say, all right, I know that s of 3, which is equal to 3 cubed over 3 minus 4 times 3 plus c, is equal to 8, because it says here that s of 3 equals 8. s of 3 equals 8. All right, and it also equals all this stuff. So now I can use that to solve for c. 27 over 3 is 9. 9 minus 12 plus c equals 8. Negative 3 plus c equals 8. c equals 11. Then I can take that c equals 11 and I can plug it back in over here. So I'm actually going to rewrite this. You probably wouldn't have to, but I'm going to rewrite this line from up here. Remember, s of t equals t cubed over 3 minus 4t plus c, and what we just found out is that the c is 11. All right. So now I can write a complete equation for s of t. s of t equals t cubed over 3 minus 4t plus 11. All right, so now in terms of answering my question, I have s of t as a function, I have a of t as a function, and v of t, which was given. So my job was to get an equation for s of t, v of t, and a of t, and here they are. Not in order, v of t, a of t, s of t. All right, there you go. So we'll do a little bit harder one next.